All right, in this example, this is number 7 off of the basic trigonometry and right triangles worksheet. In this example, we are trying to go the opposite direction and solve for the angle measure. In this case, it's indicated by a question mark. Well, this is going to be our reference angle, or a commonly used symbol is our theta symbol. So in this case, we're trying to find that theta, that angle measurement. So we're going to still use, anytime we're trying to relate the side lengths of a right triangle to an angle measure, that implies that we need to use the trig functions, sine, cosine, or tangent. So as just a reminder, I'm going to write our trig functions up here. So sine is opposite over hypotenuse. Cosine is the adjacent over hypotenuse. And tangent is the opposite over the adjacent. Anytime we're using a trig function in a problem, the first thing we have to do is identify our sides, right? So I generally start with the hypotenuse, so I identify that one first, because for me that's the easiest one to locate. It's always the longest side. So in this problem, my hypotenuse is given to me. The side across from your reference angle. So the side across from your reference angle is your opposite side. And then the remaining side, the last one I typically label, is the adjacent side. So in this problem, we know 2 of the sides, but not the third side. So the side we don't know in this problem is the opposite side, so we're not going to worry about that one. We're not going to use the opposite side. So then I need to identify which of the 3 trig functions uses the adjacent side and the hypotenuse. So if I look here, sine uses opposite and hypotenuse. Well, I've got the opposite side marked out, so I'm not using that one. Tangent uses the opposite side. So since my opposite side is marked out, I can't use tangent. So that means my good trig function for this problem would be cosine. So just as a reminder, our trig function formula looks like this. Cosine theta equals the adjacent side excuse me, the adjacent side over the hypotenuse. All right, so I fill in every number, every value that I'm given. So I'm going to rewrite my formula. So cosine, in this case, I don't know theta. That's what I'm trying to solve for. So I leave my theta. If you write a question mark here, because that's what's in our problem initially, that's fine too. And now we fill in our 2 values for the adjacent side, which is 17, over the hypotenuse, which is 21. So now, since what I'm trying to solve for is embedded, is part of my cosine function, I always have to isolate my unknown, my variable. So in this case, my variable is the theta. So that means I've got to do something to cancel this cosine function. So the opposite of cosine, because we always have to use the opposite operation, like addition, opposite is subtraction. Multiplication, opposite is division. So a trig function, its opposite is called the inverse trig function. So this would be the inverse cosine. So I am going to use that inverse to cancel my cosine function. So I'll end up with cosine -1 times cosine of theta equals, well, what did I include over on the left side? Would be my cosine -1, 17/21. So on the left side, your inverse cosine, your cosine are going to cancel each other out, just like all your other opposite operations do. So that's going to leave me with theta is equal to inverse cosine of my ratio, 17/21. So this is what we're going to use when we know our full ratio. We know our two sides, but we're trying to solve for the angle measure. So this is what I need to type into my calculator. So we go to our handy dandy calculator, and I need to type in inverse cosine. Well, that's easy to do, because if you know where your trig functions are, sine, cosine, tangent, your inverses are the second operations. So if I hit second cosine, that gives me that cosine -1. So if I look here, I need cosine -1. And then my ratio is 17/21. So I type in 17 divided by 21. Close your parentheses. Double check, make sure we have everything right. Cosine -1, 17/21 inside my parentheses. I hit enter, and I get 35.95, or could round that up to 36. So then my angle measure in this problem is 35.95 degrees. So that would be your answer.